Hello, everyone. I think it's 9 a.m. and I think we can get started with this tutorial about running BGP in 2019. So I just want to warm you up before the main section, and we would be talking about some BGP stuff that is going on in recent years, and we begin nice and slowly with all the good practices that I really hope you are familiar with, and ended up with some unresolved questions in this BGP area. And I really hope that I will get a valuable feedback from you at the end of this tutorial, because I really need these answers. But first things first, and why we? There are different people that are running BGP and that have an experience in this sphere, and they have their own operational considerations in them. First of all, I'm working at a DDoS mitigation company, and so our main goal is to protect our network from evil bot networks, and this is why we are needed to be as close to a source of an attack as it possible. So we need to be presented in the region. And also this presentation can help us to say to our potential customers that, okay, we are presented in your region, and so your local application will have a very low RTT for your local customers, and so on. But there is another question, where we needed to place our nodes in this region, and to whom we needed to be connected. This is why a radar project was created in the first places, and we were making an agreement with different BGP speakers all over the world, and by gathering information from them, getting their own routes to these prefixes, and thus we're having a complete not complete, but sufficient internet picture of all of BGP routes, and by analyzing them, we can understand who is a big providers, who is a better, where is a better place to be connected at, and so on. And during this BGP monitoring, there were found different interesting cases of BGP issues, such as route leaks and on, and so we decided to not only use this project internally for our company, but also to provide some instruments for other operators for their own good, for analyzing these kind of problems. So I have experience in analyzing BGP problems, and this is why my slides is slightly different from what you're expecting. But what you are expecting, I think you already reached the agenda for this presentation. And so we will take some time and we'll talk about good manners in the internet. Also, if you are having some problem in your own network, there are some toolsets that will help you to analyze this problem more quickly and to find a guilty party and an answer on a question, what can be done to reduce the consequences of this attack. Also, we will take a look on modern trends, because it's a sphere that I'm most familiar with, and also we will end up with a party. Yay. But because I have not enough NOC experience, I will not get into some spheres that I'm not familiar with, or less familiar with. So you will not find any examples of a configuration, how to set up your router, or what commands you will need to type into a command line to get what you wanted. Also, I will not talk about configuration deployment and automation, validation, and so on. And there is another big topic, and I have not enough time to speak about all the route reflex configurations, and using BGP in data centers, using BGP as a transport, and so on. It's a really big sphere, and I just want to highlight other problems. And also, I am not considering myself as an expert in this sphere, and this is why thinking twice before applying any of the recommendations that I will give you with this presentation. But let's move to the imagined world. I'm a beginner ASP. What I want to do? I just became a leader and bought some of IP address block from my provider, and also register my own ISAN. I just want to make an announcement of these prefixes to the world. I even don't want to set up a configuration by myself. I just wanted things to be done, and don't get into this sphere anymore, because there is applications that must be running and so on. And network problems, I really don't want to meet with them. But we all know there are a problem of different kinds. And on this slide, you can find only some of them. First of all, if you're thinking that there is a RFC draft that were suggested and confirmed by a working group, and it would immediately implemented by the vendors, you are wrong. It took some time, and also there are many routes that are pretty old, don't update it, the software, and so on. So many of modern features you don't find on them. Also, some hardware are such old that they don't support it even a current overload of a full view, and there were some message in some of the channel about a router that could not support 768 routes, and what can be done. So yeah, the reality is not that you expected. Also, when your network grown bigger, you needed to set up a configuration on your different routers. Don't forget to update your routers. It's another common problem. Also, you can make bad decisions and make something bad by applying your configuration without any validation. And also, last but not least, there are different bad guys in a network that are trying to ruin your business, trying to get traffic from your customers, and get a profit from your users. So we are having a problem all around the world. And as an analytic, I like when other people make a mistake, because it's really interesting to investigate them. And it can create an interesting story that you can write about. But it's rather an exception. And if you are an SP, you are trying to avoid as much of this problem as possible. If you are finding a problem, you are trying to finding a root of this problem as quickly as possible. And if you are finding a root, you are trying to mitigate this problem and making sequences of this problem as least as possible. So let's talk about prevention first. And first of all, this presentation appeared after we discussed some internal problem in some group of people, and this group of people decided that there is no good operational standard for BGP, because each of this group remembers that yes, there was some presentation in the past, but there is no standard for them. And actually, when I was preparing to this presentation, I found out that yes, there is already one, and it covers most of the problems with a prefix filtration, and we'll get to them later. Also, there is one guy, I think you all know him, that have some operational problems finding a solution. Pretty often they are crunches, but whatever, and making them is an RFC draft. And so if you want to know current operational problem, you can look at his presentation. And also, if you wanted to find some example of filter codes, you can follow the link on this slide and find out what can be done on your routers today. And they have example of code for Juniper, Cisco, and so on. But firstly, let's take some time and talk about TCP security, because BGP is running on TCP, and BGP have internal mechanism to protect it. First of all, we are using these security mechanisms to prevent against active autocare, not from accidental errors. And so, if you wanted to prevent from MITM, you can create a cryptographic hash to all of your TCP segments. And if you're trying to convince other parties to use the same password, you can trying to achieve this goal. Also, attacker can try to get rid of other your resources, and for example can try to overload your max limit of TCP open connection, and thus very basic ACL filter to accept all of your BGP connections from known neighbors to port 178 will save a day. But there is another problem. There is a spoofing attacks, and they will pass through this ACL filter. So a TTL hack will help you, and you can say that I want to receive packets only from my direct customers, and by applying both ACL and GGCM, you can try to avoid nearly all of spoof attacks in the wild. And it can be even applied on multi-hop sessions, but there is a much less good reason for doing that. And so let's move to some boring stuff. I hope you're all familiar with them, but I'll take the time and discuss all of them really quick. First of all, there are some prefixes that are not be globally propagated, so you should not propagate them to your neighbors. It's simple and quite logical. Also, there is some rules that say that you are not supposed to announce more specific than /24 and /48, and this is why in other cases your routing table will be too big and modern routes will not support them. And also you would not want to accept XP prefixes and local prefixes in all directions. In XP cases, you don't want to support them from neighbors because it will, on a router server, because it will break your connectivity. And your local prefix is not from other part of your organization with their own license, because why they do so and why they need to announce your prefixes why your prefixes need to be announced by the third party. But let's move to more interesting part. And I really met some providers that saying that I give an IP block to my customers and I can just whitelist this block. And so it will be a great filter to this customer. But now, because there are, for the two main reasons. First of all, your customers can have a provider independent block. And secondly, your customer can be a multi-homed one, and so they can use another block from another transit provider, and you should allow to use it. So if you're applying this customer whitelist, you'll be really careful of whom you are trying to support with. And there is another technique that is rather more commonly used and pretty often appeared in our sphere, and it's a prefix filter that is based on IRR information, and particularly on IS sets with routes objects. And we will return to it in a few slides. So yeah, we have a prefix filters, but what can be else done? And there is another kind of filters that can be applied on IS path, and the most important one from them is not even a tier 1 filter, but a neighbor check. And I'll explain it. First of all, what is neighbor check? If you're receiving a route from your neighbor, and the last ISN in this IS path of this route is not your neighbor ISN, you should drop with this route. It's simple, and there is one good exception is when you're applying on a route server. This is a particular type of case when this neighbor check should not be done, but in all other cases you should apply this, and it will help us with ISPath manipulation in the future, and we also return to it. But let's take a look on tier 1 filtration. What it's saying: if you're receiving a route from your customer peer and it's having a tier 1 ISN in your ISPath, you should drop this route, because in most cases it's a route leak, and route leaks are bad. But why they are bad? First of all, what is route leak? Route leak is the type of situation when you are receiving a prefix from your peer or provider and announcing it to another peer or provider. And violation of policy is bad. Everyone knows it. But it has some more consequences just as bad practice. Because if a number of prefixes is too big, I'll make a step before and saying that first of all, most ISP prefer customer routes to peers and peer routes to providers. And so if you're having two routes, a leaked one and a normal one, you will prefer a leaked one. And so traffic will traverse alongside with this leaked route. And so if the number of leaked route is big enough, the enough amount of traffic will traverse into wrong direction. And if your hardware and links are not ready for this type of computation and so on, they will be overloaded and they will be turned off and it will result in DOS. So prefix rate limiting, and by saying it, I'm saying that you will limit a number of routes that you will receive for during 1 minute or so on. You can just avoid the biggest of route leaks and trying to avoid the worst of the impact that could be done. But what if you want to apply this policy? You can be making this by choosing your own custom communities in your network, applying them on your egress and ingress filters, and so you can just implement this policy and you will be good. But custom communities for every one operator that will be chosen independently and will be supported independently seems a little bit of redundancy. And so we decided to make an automation of this by creating a special BGP roles. And so when it will became a BGP standard, it will solve this problem. When it will be applied by vendors and when the ISP operator will apply this modern software in the network. But there is one problem. We are on this way for 3 years and I really hope that it will become a standard in this year, but we just needed to wait and it's really bothering me. But let's return to the community. Community is a great way to apply any policies that you wanted to imply in your network. And all communities have a problem in them. They were for bytes length and they don't support for byte ISNs. And this is why 1 or 2 years ago, large communities appear. And actually, there is an informational draft of how you can use it for most of your cases. So you can just get familiar with them by following the link. Also, I forget to say that all the highlighted words are links to a particular presentation or so on. And so by downloading this presentation, you can just continue your getting familiar with these resources. Okay, and also you can study your upstream capabilities of your upstream provider. What does it mean? For example, we are using many transnational operators as our providers, but we want to stay in the region. And in most cases, if this operator is transnational, his ISPath length will be lower than an ISPath length of a series of hops making by different ISP operators in a particular region. And so we want to stay in the region even if we are using these big ones. So we can use these geo communities and just saying that if our node is on the Europe region, don't announce these unknowns by your inner structure anywhere else. And also just study your upstream capabilities because they can suggest you pretty much of functionality that you don't think they can be doing. Okay, and when I was preparing to this presentation, I met up with a a few suggestions that I'm not fully agree. And first was to aggregate your customer routes if you are a transit ISP. And what's it mean? First of all, there are two methods for aggregation. And first is to use a standard BGP approach, and it will result in iSet, atomic aggregate, and so on. And iSet are bad, and I really hope that they will be deprecated in the nearest future, because they break any ISP pass checking and validation, and also they are broken error records. So there is another approach, and it's result in blocking all of your customer routes and don't announce them anything further, and just announce your own address space. And it has the same problems that a static prefix whitelist, so it will have some problems with a prefix provider independent blocks, and also with multi-homed customers. Also, you see a label on this presentation, and I really hope that I have some of the feedback about the questions that are highlighted in slides with this label. So my question is, do actually we need an aggregation, and also who is supporting such kind of policy in their own networks? And if we really have such a bad time with a number of routes that are appearing in a for view. Also, there is another suggestion about iSPAS length, and it's a more a reasonable one, because distance in the internet is not so big, and even the worst of valid iSPAS can be not longer than, for example, 20 ISNs. And so they can be filtered out. But what is the problem? First of all, RFC says that if iSPAS is not fitting in one iSequence segment, it should be transferred to another iSequence segment. So in RFC was not a suggestion, but okay, let's be a suggestion to support very long iSPASes, and so they have such a capability in them. But as we can see for the last 10 of years, there were some cases when implementations were not ready for them. And if iSPAS is not fitting into one iSequence, we're having a problem. First case is about famous 252 prepend policy. The second one is a Quagga bug that resulted in routers turning off, and it happened around half a year before. So the question is if we needed to make this policy as a standard, and if we are really needed to where to choose a border, and which border would be sufficient for this type of actions. Okay, and if you're making all these policies, you prevent it from most of the errors. But there are some errors that can still be getting into your network, and you are needed to find them and also trying to mitigate them. But how to understand that there is a problem? First of all, you have an application metrics, and if they are good, you don't be worried about anything. But if they're wrong, you can take a look at different network metrics. For example, a sudden raise or drop in a traffic, decreased number of users, and so on. In my cases, I just use a flag raised by anyone else that's saying that, yeah, this particular ISP having a problem, maybe it's BGP. So if you're having a problem, you're trying to understand what is the nature of the problem, and if it's really BGP or DNS or some problem on the links and so on. And if it's BGP, if it's a standard one, is it hijack, hijack, and so on. Why we need to understand if it's a standard one? Because we really know to do how to find a guilty party, what will be a responsible method for them, and so on. And if it's an unfamiliar problem, we just need to follow these simple rules. So guilty party, what can be done, and how quickly it can be done. But in most cases, network problem is a problem outside, made by third party. It's not a problem that was made it by your own network. So you needed some instruments that will provide you with such an external data. And there are some kind of tools that can help you with this. And for example, Right Atlas will provide you with data plane information. RapVidgets will really help you with routes, and so on. But in most cases, when we are talking about BGP programs, we will end up with analyzing a route. And if you need a route from around the world, you need some kind of raw data. And there are 3 projects that provided you with this data. But the problem is that this data is in MRT format, and in most of the cases, you don't really need it to parse it but yourself. It happened to me once or twice a year when I really needed to dive into a particular MRT file and analyzing it by myself. In most cases, you can just use a framework or library to do all the hard work for yourself. And the second one is a framework that are provided by Kaida. And in most cases, you even don't need to find out what is the state of all your current routes. You need to find a different, because if you have a good state and bad state, you can find a different and find out what was changed, and thus finding a guilty party. And this is why BGP Play is an only option for visualization, for making a visualization for this process, but it have a really long delay. And if you find out a real-time problem, you need something else. But what can be done? First of all, you needed to find out what type of users were affected by this incident. And this exactly type of situation when RIPE Atlas can help you. And we even provide a framework that avoided some limitations of it and make a nice visualization with maps. But the main problem with RIPE Atlas is that it using a credit system, and so it can be used to find out the reasons and effects of a particular problem, but you cannot use it for a constantly periodic network health monitoring. So if you are talking about with nearly every of the operators, they will say that if I want to analyze a route, I will go to a looking glass of a particular operator and look at a situation on this particular network. So yeah, it's great, but we have not a standard for looking glasses. They are all custom, and you need to analyze it, every one of it, with a new approach. You cannot use some API or so on with them. And this is really bad approach. Other alternatives. First of all, you can use a RIPE API. And actually they have a method that just highlighted all the routes that you are receiving by their RIPE risk collectors in a nice looking JSON, and you just need to parse them, and you can find out all the routes, all the communities, and so on with one particular request. And also you can just use our API that provided you with the passes that we are seeing for these particular prefixes. And we are providing only a pass because we are trying to don't give you any unrelated data that will bother you and so on. And this pass will be enough. Why this pass will be enough? Because this pass can help you to find an attacker. And what if an attacker wants to hide himself? Because we see he can change an IS path to whatever value that he wants. But the main problem for an attacker is that he cannot change his own neighbor ISN if he announces a route to someone else. He just needed to put his ISN in his announced IS path. And if you have enough of routes, you can find out that, yeah, this is an attacker. And this is a bad guy. And something should to be done with him. What can be done with him? First of all, you can write a complaint for him by using an abuse contract and wait. Or just write to his upstream provider, convince him that, yeah, this is a bad guy, can you just block his route from announcing somewhere else in a global? And also wait. Or just write a compliant to a special mailing list and also wait. Okay, I think you all follow the... I think you all find the similar in all these cases. You must wait. What if I want to make an active countermeasures to a problem? I found out a BGP problem. I just needed this problem to be solved. First of all, if you are accepting a better route from your bad neighbor, you can just filter these routes out. Okay, but if your address space is under attack, maybe these better routes are even not transferred through your ISP, because, for example, in hijack, the attacker will try to redirect all its traffic for yourself, and you will just not see even this route. So what can be done in these particular cases? In case of traffic redirection, you can try to announce a more specific announces, and thus returning all your traffic to yourself. And if an attacker announcing the most specific announce, it will be a battle of ISPath licenses, and the part that have a better ISPath connectivity will win. So you can try to delegate this type of mitigation to parts or ISPs that have this kind of good connectivity. So it can be clouds, it can be DDoS mitigators, it can be SDNs, or so on. In case of route leaks, you can try to use a BGP loop detection mechanism to your own and just add a leaker for your ISPath. And thus this route will be dropped on the border of his RSN. Okay, but let's move on modern trends. And let's talk more about security. First of all, there are two main directions. First direction is about making operators doing more errors in their configuration, and it can be reached by making operators use an explicit configuration, write explicitly the intent in the configuration, and so on, or by making some automation of this process. And the second part is to making a part a little bit easier, and this is a particular kind of problem that there was a problem, there was some kind of solution, it became a draft. About large communities I was talking before, graceful shutdown is a type of community that can be labeled on route, and this route will be deprioritized on all the directions that it will be announced, and we want to use this graceful shutdown in our own solutions and so on. And shutdown communication, it just human readable logs for network admins to try to better and quickly understand what is going on and why this particular BGP session is going down. But let's move to more interesting part. And during the last year, there was a suggestion to resurrect URPF. What is URPF? URPF is an anti-spoofing technique, and it's directed to block out a packet with spoofed IP address. But how we can understand that this particular IP address was spoofed? They suggest to use a BGP routes for them. But the main problem with BGP routes is that they have asymmetric nature. What it means? It means that if you have 2 points, A and B, then the best route from A to B can be completely different from a best route from B to A. So the traffic will traverse through different paths between these 2 points. And the most asymmetric as BGP can be is when ISP decided to use a traffic engineering for load balancing, for providing backup providers, and so on. And modern driver, the most recent draft is trying to solve this problem, but for its pity, there are corner cases when a link is used as a completely backup and and the operator don't announce any announces in it, and this particular case is just ruins this draft. So the main question is anyone else in the auditory just use your PF and not the loose one? And let's talk about security some more. And first of all, as it was saying some time before, you can change anything in a route. You can change a prefix, you can change ISPath, you can change any other attribute. But in most cases, you just need to make a secure measures to prefix and some kind of ISPath, or to origin ISN in this ISPath, or to ISPath itself, because ISPath is used in most of the analytics because it's a known attribute that can be used for analytics. So just can we make just this attribute more secure than before? Okay, let's start with prefix origin validation. And as it was saying, that is based on a combination of iSet objects and route objects. By using iSet objects, you can create a customer con, and we all know problems when you're using such technique. Then you can just get a corresponding route objects for these iSets, and thus creating a prefix filter. What's the problems? First of all, you cannot find a problem that appears in your customer con when one operator from your customer con attacked another operator in your customer con. And also, there are problems with sets, there are problems with route objects. What problems with route objects? First of all, they have not any max length at all. And you can just, you must choose what prefix filter you need to use. Exact tab when any prefixes that are not equal to which was announced in a route object should be dropped, or you should accept any more specific of the prefix from the route object. And any of this option has some limitations in it. And also we have no any formal policy in a RIPE or other RIR for doing such stuff. And the most interesting one is what should be done when you are delegating your IP address block to your customers and announces prefixes from these delegated prefixes by yourself. Should it be dropped or should it be accepted, and so on. And in accordance with max length problem, we should define does we really need it to this policy to be supported and work to be start in RIPE VG, and what kind of decisions should be made for it. But let's move to RAW. And it's interesting, it's not a first RAW signing party, and the last signing party was taking place on a Enoch session. And you can see some problems in this slide. And in suggestions that they were suggest. Actually, these particular ones. They suggest to use max length. And it's understandable because, for example, you needed to have a black hole capability when you are trying to black hole a specific IP address, and you're thinking it should be valid. And this is why you can sign only aggregates, because it to make a less raw records, and you needed to sign more amount of records that should be done. But if we're trying to remember why we needed raw records, we needed them to prevent you from, to protect you from hijacks. And so hijacker just can use these more specific prefixes in his own good, and by using them, if max length allowing him to use that, just redirecting traffic to itself. There are some valid cases when max length should be greater than prefix length. For example, in our case, we use it to prevent our routes from be stuck in some part of the world. For example, we announce in /23, and if it's stuck, we are just announce /24 to get our traffic back. So yes, there are some cases when max length should be bad, but is this case more valuable than a possibility of hijacks? The recent draft suggests that not, and max length should be deprecated. And if you want to use black hole prefixes, you just needed to place this rule more higher in your route map than a drop and valid policy. But there are another problem that worried me. It's saying that if a prefix with origin are not covered with a particular row, it should be not found. And not found should be deprioritized, should have a lower local preference, but should not be dropped. Why is bad? If we can remember, there are URPF that, for example, support this, that support the decisions, and it's based on BGP routes. And if we have a less specific, for example, 4/1, we can use any IP address from this block. So if we want to spoof, this is a great example when we can done such type of action. And secondly, less specific is better because you are redirecting all of unrouted traffic to yourself. This is first kind of this first side of problem. But second side is if some particular region in the world don't see your routes, they will be redirected to this particular less specific. And if there is some possibility to drop your valid route, this particular kind of attack, kind of situation with this attack will be much more harmful. And last but not least, let's return to iSpace manipulation. It's all based on effect that BGP route should be dropped if ISP sees his own ISN in the route. And if I was saying before, it can be used in route leak prevention, but also there are two academic works that are saying that, yeah, we can use this type of mechanism to redirect traffic to a particular link. And if this link was not loaded before, we can use it for load balancing. And if this link is critical, we can overload it and just ruin some particular infrastructure. And last but not least, it can be used in subprefix hijacking. And most interesting, we are seeing this particular type of attack in the wild during the last months. And we want to protect ourselves from iSpace manipulation because it's not a good thing. We have a BGP SEC, and we all know the problems and limitations with them because it sign up every route and signed up any segment of iSpace and prefixes with it. It protected iSpace and prefix, you cannot change them, but first of all, you need to sign every route, and for every direction you have desired to announce it. It also not protected from more specific type of attacks, and the cryptographic load is really high. Another suggestion is our framework, ASPA, and it's based on the fact that if you are accepting a route from customer or peer, it should have only customer to provided links in it. So you can just check a validity of these links, and it will save you from preterm-formed iSpaces. And attacker needs to construct a valid path to a target to achieve his goals. So he will be very limited. But there is some limitation, and one of the example was shown on a previous slide with this kind of attack when a transit provider announces a more specific use a valid iSpace and use this valid iSpace with announcing of more specific routes, and thus redirecting all the traffic from itself and getting rid of other ISPs that providing services to his customer and his customer con. So ASPA would not save from all the attacks, but it's still better than a current decision because it's not spread at all, even if it's a RFC standard for some time. Okay, and let's move to the party. And first of all, I'm gladly to say that after applying a drop invalid policy on Tier 1 operators and some of the XPs, small operator decided to sign the prefixes with raw. It's really a good movement, and we can try to make it even better and support it even further. And actually, in the region, around 20% of operators have already signed off all of the prefixes, which is really great. And how we can check that there are some prefixes that needed your attention. First of all of modern prefix monitors just support this type of functionality, and you can just check the status of a corresponding for each of corresponding prefixes. If you don't like a website, you can use an API. For example, first are provided with by RIPE, and you can just check RPKI status by inserting a particular ISN prefix, or just get information for all of your prefixes for your particular ISN by using our API, or just use an RPKI dashboard. Why we are talking about RPKI dashboard? Because we are lazy. We don't want to set up our own RPKI repository and follow all the standards that are described in this repository. We want to only sign our raw. We don't, for example, believe in BGP or so on. So first problem is to wisely choose which prefixes and which mark sense you want to sign. And there were problems that were described before. There is a dilemma between good cases and hijacks. Then you just need to follow to RPKI dashboard, and they have really a great UX in it, and just follow your intuition, and it will help you to sign your prefixes. And this is all. I really hope you follow this kind of recommendation and sign your address space today, because even a row with max length equal to max is much more better than don't having any row record at all. And if you remember, I have some questions in my presentation, and I would like to have some more feedback. And if you have a suggestion on this question, you can just find out, step up to microphone, or just write me an email with your suggestion to these questions, because it's really important to me to know what operators are thinking of any of this problem.